So here we're going to say, let x be a normal distribution with mean equal 20 and standard deviation equal to 3. Find the probability that x is less than 25. Okay, so we're going to look at P x is less than 25. Now, what I would like to do is I'd like to convert the x back into a z. The z is the standard normal, and the z represents the number of standard deviations above or below the mean. Z equals then x minus the mean divided by the standard deviation. Now let's give some symbols to make this a little simpler for us. We use this symbol mu for the mean. So in our case we're going to say the mean here is 20. We also use the symbol x bar, actually the line on top, for mean. They're slightly different, but you don't have to concern yourself too much with that. And we use this symbol, which is a Greek lowercase sigma, for standard deviation. And we say sigma is 3. So making the substitution, we can certainly say that z is x minus mean, so x minus 20 is x minus mu, divided by the standard deviation divided by sigma. So in general, that's what z is. Z is x minus mu divided by sigma. And we're going to make that change over here. We're going to rewrite this as the probability z, x minus the mean, divided by the standard deviation, is less than 25 minus 20 divided by 3. Now x minus mu over sigma is z, as we've established on the right side there. So we're going to get the probability z is less than 25 minus 25 over 3, which we will round to 1.67. Now let's visualize this. We'll draw a z distribution. 1.67 is here. We want the probability z is less than 1.67. That'll give us all the area to the left. So we're going to look at the table from the positive side. 1.67 is 9525, I believe. So what that tells us then is the probability z is less than 1.67 is going to equal about 0.9525. So if we have a normal distribution with a mean of 20 and a standard deviation of 3, a little more than 95% of the data then will be less than 25. So let's do a follow-up to that. This time we'll say, let x be a normal distribution with a mean of 75 and a standard deviation find the probability of 12. Find the probability that x is greater than 60. So what's the information that we have here? We're told that the mean is 75. I'm going to use this symbol, the Greek letter mu, to say the mean is 75. and the standard deviation is 12. We'll use the Greek symbol, lowercase sigma, to say that the standard deviation is 12. And we'll remember that z equals x minus mu divided by sigma. Now the question is asking us to determine the probability x is greater than 60. So if we're going to do this, we're going to take the probability x minus mu over 60 is greater than 60 minus, what is the mean? The mean is 75, divided by, what is the standard deviation? Standard deviation is 12. So we get the probability z is greater than 60 minus 75, divided by 12, gives me negative 1.25. So let's visualize that. So we're going to take a look at a z distribution. Z distribution is here. Negative 1.25 is on the left side. But what we want this time is greater than. You'll notice our symbol here is greater than. Z is greater than negative 1.25. So that's going to correspond to all of this area. That's what I'm interested in doing. But that's not what the z table gives me. The z table gives me everything to the left of negative 1.25. So let me go ahead and find out what that is. And that is 0.1056. So 1056 is to the left. So if I want the area to the right, I've got to take 1 minus the area to the left. So 1 minus the probability z is less than negative 1.25 will become 1 minus 0.1056, which gives me 0.8944. Let's take a look at another problem in the same sort of world. This time we'll say let x be a normal distribution. With a mean of 120 and a standard deviation of 34. And this time we'll say find the probability that x is between $80 and 140. So our question will be phrased this way. Probability 80 is less than x is less than 140. Now, what's the information that we know? We're told the mean is 120. We are told the standard deviation is 34. So let's go ahead and make that substitution. We're going to replace the x in the middle here with x minus mu over sigma. So in the middle, x minus mu over sigma. So that will be 80 will turn into 80 minus the mean of 120 divided by the standard deviation of 34 is less than 140 will turn into 140 minus the mean of 120 divided by the standard deviation of 34. Rounded to 2 decimal places, this becomes the probability negative 1.18 is less than z is less than 0.59. So that's the best we can do with that one, looking at those numbers. Now to answer that, we've got to find the area between those two. If we look at our z, remember, of course, z is x minus mu over sigma. If you look at our z table, look at our z graph, we are between negative 1.18, which is here, and 0.59, which is here. All of this stuff fits in the middle. So I've got to take the area we're to the left of 0.59 minus the area to the left of negative 1.18. So to use the z table, we'll rewrite this as the probability z is less than 0.59 minus the probability z is less than negative 1.18. Less than 0.59 is going to give me 0.7224, looking at the z table, minus 0.1190. If you subtract those, 0.7224 minus 0.1190, that's what I should have said, gives us 0.6034. So that tells us that if we have a normal distributed random variable with a mean of 120 and a standard deviation of 34, a little more than 60% of those data points are between 80 and 140. Let's stick with that same last question. So we'll say, given a normal distribution, with a mean of 120 and a standard deviation of 34, find the x scores that correspond to the 58th percentile and the 12th percentile. So if we're looking for P58, we want to find the z-score first. So looking at a z, we want the z-score that will be better than 58% of the population. So I need 0.5800 there. I want to find the z-score that corresponds to 0.5800. And if I look at 0.21, 0.21 gives me a probability of 0.5832. So that's the first one that's a little bit more than 0.58, so let's go with the z of 0.21. Now what do we know? We know z equals x minus mu over sigma. So if we make the substitution, z is 0.21 equals x minus the mean in this case is what? What are we told? The mean is 120. And the standard deviation is 34. So we multiply both sides by 34. What's that going to give us? 0.34, excuse me, regular 34 times 0.21 is going to equal x minus 120. So if I add 120 to both sides, what am I going to get? 120 plus 34 times 0.21. What will that give me? 120 plus 34 times 0.21 gives me 127.14. And that'll be my best answer for P58. Now, regarding P12, again, I've got to find the z-score that corresponds to 12%. And if I'm just going to beat 12%, it's going to be something on the left side of the distribution. So we'll look for that. And my best answer for that is z is negative 1.17. So again, doing the analysis, we know that z is x minus mu over sigma. So z, negative 1.17, is x minus the mean of 120 divided by the standard deviation of 34. So 34 times negative 1.17 is x minus 120. So I get 120 plus 34 times negative 1.17 is x. So what will that give us? 120 plus 34 times negative 1.17 gives us 80.22. And that'll be our best answer for that question, and that will conclude this lesson.